How many of you have ever visited a country where the unit of measurement is different than what we use here in the U.S., whether their temperature is measured differently or their distance is measured differently? Carter, where?
Guatemala.
Okay, what do they use in Guatemala?
Meters and Celsius.
And they do use Celsius, okay. Italy. And what do they use in Italy? Metric, okay. China, what does China use? The metric system. And? Okay. Anybody know any other countries that actually use the same measuring system that we use? The imperial measuring system? No, Canada is strictly metric. Yeah. Not the only one, there are two. I Googled it this morning. Myanmar, or Burma is also called, I mean, it's the same name, Myanmar. Did you Google it too? Okay. All right, there's one other one. Okay, it's called Liberia. Those are the only other two countries besides us that we really just need to get on the ball and get the same. But it is confusing, especially if you drive like into Canada and they're like, you know, they're like, woo, it's 28 degrees. And you're like, 28 degrees, what the heck? But 28 degrees is the exact same as 82 degrees in Fahrenheit. So they're pretty excited on a 28 degree day. It sounds great. But it takes a while for your mind to like get used to it and get used to what when they talk about like, oh, the speed limit's 110. You're like, 110? You know, that's kilometers. Yeah, they call it clicks. And instead of saying kilometers per hour, they often will just say clicks. It's like on the ocean, right? So that's saying nautical miles per hour, they say knots. And then if they say kilometers per hour, they just say clicks instead. Anyway, you have to imagine that in trig now, we are entering a different country. And so we are changing our system of how we measure things. That doesn't mean it's any longer or shorter than what it is. It's just measured with a different unit. All right, so when we were with triangles, the easier unit to use was degrees. Now that we move into circles, the easier unit to do is radian. Okay, all right, so let's go with what we worked with some parallelograms, things like that. Okay, any four-sided figure, any four-sided polygon is worth 360 degrees. Okay, a circle is also worth 360 degrees. But it's easier in trig to call circles by a different unit. So I'm going to slide this up a little bit here. Okay, it is 2 pi radians. Pi is like the unit. Just like degree, we use the little symbol. In radians, pi gives you the clue that we are doing radians. Those two things are exactly the same. So let's talk about some common measures. These common measures you should commit to memory. Just like you know that 12 inches make a foot. These are some things, 60 minutes make an hour. These are some common measurements that you should have memorized without your calculator. All right, so the first one we just did, that 360 degrees is equal to 2 pi radians. Well, once you memorize that, you'll be able to figure out lots of the other common measurements. For example, the next easiest one to figure out is 180 degrees. All right, so half as many degrees, half as many radians. So how many? 1 pi radians. Okay, again, common measurement, 90 degrees. Okay, so half as many degrees again. How many radians? Half. All right, so we know that a parallelogram or a quadrilateral has 360 degrees. We know that a triangle has 180 degrees. What common shape is 90 degrees? Or common figure that we work with? A right angle, okay? Also a quadrant. So I want to pause right now and talk about how quadrants go. So under the 90 degrees, can you draw a quadrant 1? But also under the radians, could you draw a quadrant 1? In degrees, when we're measuring, we put the 0 here at the top, and then we measure clockwise. Okay, so when you're in degree mode and you're measuring bearing, we always start at north and we measure our degrees that way. So you get 90 degrees for the whole quadrant. In radians, your 0 goes down here and you put a pi on it, which tells the person who's looking at your paper or quiz that you are in radian instead of degree, so that's why the symbol is important. And we measure this way. And then you get to half pi by the time you get all the way to the top. And so we would put 90 degrees down here, but in radian, we're going to put 1/2 pi radian at the top. So not only it's like going to England, and not only are you measuring things with a different unit, you're also going on the opposite side of the road. So when we switch from degrees to radians, not only are we switching our unit, but we're switching our direction. And instead of going clockwise, we now go counterclockwise. All right, well, we're following the pattern of halves, so let's keep going with some common things that we should do. Let's do half as many degrees again. So halfway through the quadrant would be the same either way. Okay, whether you approached it from the top down or you approached it from the bottom up, you would meet halfway. So that would be 45 degrees. If we're following the theme of half, how many radians is that? 1/4. So half of half is 1/4 pi radians. Now I'm not going to go half again, because then we get to decimals. Half of 35 is a decimal. But a common one is 30. So the easiest way to think of that is to relate it back up to 90. 30 degrees is a portion of 90 degrees. What portion of 90 degrees is it? It is 1/3. Okay, 30 degrees is a third of 90. So you want to take your 90 degree measurement, let me move it over a little bit, which is 1/2 pi, and you want to multiply it by 1/3. So then you get 1/6 pi radians. Okay, another common one it's good to know is 60. Remember how you did all of these angles when you're 30, 60, 90 triangle, 45, 40? I mean, these numbers are going to be very common. 30s, 60s, 45s, 90s, 180s, all very common. All right, 60 degrees. You can do 60 degrees a couple different ways. Okay, so give me some ways we can relate 60 degrees to some of the other ones we've already done. It's 2 of the 30s, sure. Okay, so it's double of 30. Okay, how else could you think of it? 1/3 of 180. You could do it either way. All right, so you could take double of 30. 30 was 1/6 pi, and you could double it. Or you could do 180, which was 1 pi, and you could do 1/3 of that. Either way, you get 1/3 pi radians. All right, so these are ones that without a calculator, I expect you to be able to know. I would expect you to be able to do 120. Okay, well, the easiest way I think to do that is to double 60. Once you know 60, just double what you had for 60, which is 2 times 1/3 pi. That gives me 2/3 pi radians. So those are about the major ones that you're going to need. Okay, 360 is kind of the starting point, and then you kind of start cutting them in half, and then once you've run out of space to cut them in half, then you start doubling or tripling or doing 1/3. All right, any questions so far? All right, so those are the ones you need to memorize, but what if I ask you to do 57 degrees or 113 degrees or something that doesn't easily cut in half or multiply by 1/3 or do something like that? Okay, well then we need our calculators and a formula. So this is called the conversion formula. And the conversion formula takes you from degrees to radians or from radians to degrees. So please notice my arrow goes both directions. You can start with degrees and end up with radians, or you can start with radians and go back to degrees. Either way. It's a cross multiplication formula, and it looks like this. 180 for a triangle is the same as 1 pi. Okay, that is the ratio. Those two things are equal. And so we start with that as one side of our cross multiplication. On the other side of the cross multiplication, the degrees go on the top and the radians go on the bottom. And then we cross multiply to solve. So this is the conversion formula to go back and forth between degrees and radians, and it's what you would use your calculator for. All right, so here's some examples. So the directions would say something like, convert between degrees and radians. So go from one to the other. And we'll do a couple for practice, but I would like you to have your calculator out. All right, let's convert 10 degrees. So you start with 180 over 1 pi equals, the 10 degrees should go on the top, and then I'm just going to put R for radians on the bottom. You can write RAD if you want, but I'm not going to do this. I don't do that kind of R, because what does that kind of R mean? All real numbers, right? So I don't write it like that. I just write regular R. Okay, so now we cross multiply. So 180 degrees times R is 10 degrees times 1 pi, which is 10 pi. I want to get R by itself so I can solve. So the easiest way to do that is to divide by 180 degrees. So R by itself is going to be, now when you reduce, you do not use the pi in your reducing. You only reduce the degrees with the degrees. So 10 degrees over 180, and you make it a fraction, never a decimal. Okay, these are always, fraction. I've been hitting fractions all year, and this is where we get to the point where you got to be, radians are measured in fractions. And so we reduce, and the unit degrees cancels each other out, so we are left with 1/18 of pi. Pi is your unit for radian measure, and it's always preceded by a fraction or a whole number, but never a decimal. Okay, part B. Yeah? Oh, well, that was exactly what I was going to do. I was going to do 27.34, but okay. All right, so what happens in that? Very good question. The math is still the same. We take 180 degrees, 180 degrees over 1 pi, and then the degrees goes on top, 27.34 degrees, over r for radians on the bottom. We cross multiply again. So we'll get 180 degrees times r on one side, and we'll get 27.34 degrees times pi on the other. And we still divide both sides by 180. So to answer your question, Dylan, you're going to need to get your calculator out and do 27.34 divided by 180 and convert the answer to a fraction. Okay? All right, so I think we're pretty much all on the same page. 137, or 1/3, there we go, 1367 over 9,000 pi. Okay, so answers in terms of fractions. We'll take a look at that. I'm not going to look at homework right now, okay? All right. All right, question C, or example C. Okay, let's take 1/5 of pi. Now we have a radian, and we want to convert it into a fraction. So we start with 180 degrees over 1 pi equals, now because this is a radian, it goes in the denominator. And I just will have maybe d for degrees in the numerator. And we will cross multiply this way. All right, so this time we end up with 1 pi times d is just pi d. 1/5 times 180 you can do on your calculator. All right, it's not like I'm going to expect you to do that in your head, but you've got 36 pi. And then we divide both sides by pi. So d is 36, and then don't forget the degree symbol because we just converted to degrees. Okay, how about 9/7 pi? That's a little bit more of an awkward fraction. So 180 degrees over 1 pi is what you start with. 9/7 goes in the denominator because it's radian, and then d for degrees in the numerator. The same process of cross multiplying. So 1 pi times d is just pi d. Okay, 180 times 9/7. Make sure you keep the result in fraction form. So it would be 180 times 9 divided by 7, which will give you an awful looking decimal. And then you need to convert that. Does anybody have the fraction for me on that one? Yep. Okay, 1620 over 7 pi, and then divide both sides by pi to get d by itself. So d is 1620 over 7, but what unit do I add on to that? Degrees. Okay. E. 2.4. We're going to convert that. All right, now sometimes people get confused because 2.4 doesn't seem to have either, is it a degree or is it a radian? Okay, which one is it? And so it's almost like a process of elimination. If it doesn't have a degree, it is a radian. Okay? If it is a degree, they'll have the degree symbol there. There are other things in math that we don't write there, but we assume that are there. For example, how do you tell the difference between a square root and a cube root? Well, the cube root has the little 3. Well, the square root, you're really supposed to write the little 2 by the same way, but nobody does, and we all just assume everybody knows it means a square root. So the same thing is true here. If there is no indication that it's a degree, you assume it's a radian. Okay? All right, so that means it goes in the denominator, 2.4. And d would be my numerator. When I cross multiply, I will get pi d equals 180 times 2.4. Okay, that gives me 432. Now I divide by pi. And I actually have to divide by pi using the pi button. Okay, before, when I was dividing by pi, there was another pi already there that I could reduce it away. That happened in the first two questions. But this one, there is no pi to reduce it away. So you actually physically need to use your calculator to divide by the pi button. So 432 divided by, use pi. So I don't know, Dylan, if that's your question. And then if you can convert that to a fraction, great. If you can't, okay, mine did. 5,64203 over 4103. Okay, mine actually converted it to a fraction. And now I do add degrees because I did convert into degrees. Yeah. Your pi button is in the same column here. It's above your division button. Do you see it?
Yeah.
Okay. All right, last one. Letter F. (42 degrees, 12 minutes). All right, the conversion is 180 over pi, 1 pi, equals, okay, because this is degrees and minutes, it goes on the top. So 42 degrees, 12 minutes goes in the numerator, and R for radians goes in the denominator. We'll cross multiply. We're going to get 180 degrees R, and we're going to get 42 degrees, 12 minutes pi. Divide by 180 degrees, and just divide that part because we want to leave pi there because this is a radian problem, and so you want pi as part of your answer. Okay, in a degrees, you don't want pi as your answer. In a radians, you do. Okay, so once again, I'm going to come walk around. I want to see you doing that in DMS and then convert it into a fraction. Okay, so 4212 in DMS divided by 180 degrees, convert that to a fraction, and then have your answer. All right, so we end up with 211 over 900, and pi is right next to it. So it's a fraction next to pi as our radians.